Hello, everyone. Thank you for coming. My name is Ankit,
I'm Shridhar.
and we'll be talking a little bit today on how to use a Llama 3.1 for voice control of dynamic web interfaces. So, to give a background of who we are, we're students at the Illinois Math and Science Academy out in Aurora. I am working in network optimization at Northwestern University, and I also do computational modeling in my research.
Hi everyone, I'm Shridhar and I've worked in assistive technology and I'm currently a full stack developer at Vismed 3D, which is a healthcare informatics company here in Chicago. And me and Ankit and I work together on our project that we'll show a bit at the end on Dexassist. And we just like to acknowledge that we worked with some professors at UIUC and U Michigan. We're excited to present it. The agenda for today, we're going to give an introduction to HCI first and talk a bit about HCI and web development, which is human computer interaction, and then talk about our research, show her some demos, and then conclude with some questions. Introduction to HCI. What is HCI? So, human computer interaction at the core is how people interact with computers and how interfaces can be designed for most effective interactions. I'm sure a lot of you guys are full stack developers and work in the front end. So, human computer interaction plays a heavy role in the front end. The primary goal is to improve the interaction between users and make computers more friendly to use. So HCI clashes with a lot of other fields like computer science, human factor engineering, and cognitive science. With computer science and HCI, people obviously write code and develop front-end interfaces for personalization, and this is like the technical foundation of HCI. HCI has been around since forever, since computers started, but recently it's been getting more popular as a lot of people more have access to like computers and getting into coding and stuff. So cognitive science in HCI is understanding how users think and process information and creating mental models. Companies like Instagram and TikTok are really big on this because they want to keep you addicted to their apps. So they really need to figure out how computers work and how humans process information. And then human factor engineering is just optimizing like more like physical systems and making them more accessible. Healthcare does a lot of this with like they're trying to make their medical devices as ergonomic as possible and as accessible. So different forms of HCI. Obviously, we have graphical user interfaces like Adobe, Windows, iOS. Then there's like voice controlled interfaces, which might be like Siri or Alexa. And then gesture-based interfaces, we're seeing more of those come out, like smart TVs or Apple Watches. And then a really big thing is virtual reality and like stuff like the Apple Vision Pro, completely changing how people are like able to interact with their computers.
Now, what does HCI actually look like in web navigation? So, HCI is all about optimizing fonts and the user experience. And it all starts with key elements like fonts, the color scheme of the website, and also the layout. Interactive interfaces with dynamic elements like hover effects and animation, chatbots, and websites that provide real-time updates are what engage users and enhance the website, making it come to life. Simplicity and minimalism is also another key area where many companies are trying to get into, and it makes web interface and the experience of the website much simpler to use and easy to navigate. Feedback and interaction is a key part. As I mentioned, hover effects, progress bars, form validation really guide a user throughout the website navigation process. But the problem is HCI looks different for all. Individuals with cognitive disabilities and fine motor impairments struggle to control their hands while using input accessories that modern computers use, such as keyboards and mouse. This can lead difficulty in controlling mouse pads or touchpads, and it can lead to overshooting or undershooting based on how much impairment they have and how limited their dexterity is with their hands. So, for example, clicking small buttons, navigating on close-spaced links or icons can be challenging for these individuals. Also, Pressing multiple keys continuously requires a degree of dexterity that some don't have, and this is seen in applications such as navigating between forms, which require like quick tabbing between fields, and shortcuts, as like commonly known, like Control C, Control V, that many of us use today without much thought. Also, tasks that require long key presses are hard for these people to use as well. Yeah, and also one more thing was controlling sliders. As I mentioned, requires stable hands and precision when navigating with touchpads, especially. So these are key elements to consider when designing website uh, for these groups of people with fine motor impairments. So here's a demonstration of hover effect on Amazon's website. As you can see, the top navigation bar is filled with icons that require you to press on them. Not just press, but simply hovering on them brings down another menu. However, since these are closely spaced, not much of it is accessible just via simple hand movements. And people with limited dexterity and coordination issues often struggle and overshoot these interfaces.
And another example was on Target's website, like the scroll bar on the right doesn't really appear until you start scrolling. And even if you do, once you hold on, like click it, you have to hold on to it to like get to the specific elements, which is significantly more difficult for people with like fine motor impairments. So like these consider it should have switched this one. So considerations like these are often overlooked and receive a little attention when it compared to like other company objectives when it comes to building their website. Obviously, companies don't want to focus too much time on this because it might be a small target audience that they're trying to help, and they don't want to invest too much money.
So, how big is this issue, and how many people are actually impacted by this? Stats reveal that 50% of people over the age of 70 struggle with tasks that require manual dexterity. Furthermore, 30 to 52% of children with ADHD have these fine motor problems. So now we'll talk about research, which pushes to combat this using a consumer end solution instead of pushing companies to invest more in web accessibility, which is kind of an uphill battle since they are required to invest large sums of money into following web accessibility guidelines that are often thorough and highly detailed to follow.
So our project was kind of to use large language models to automate web browsing. And so one of the previous works that we kind of build off was by some researchers at Princeton, Shunyu Yao and others. They trained reinforcement learning models to mimic human mouse movement and interaction sequences on these websites. And they were getting very good results on specific websites. But the issue was that the models were trained only on those specific websites, making them very like restricted and not really applicable to everywhere else. And the human, like the data training set had a relatively low accuracy at 59%. So like the training sample was obviously not this.
Yeah. Also, researchers at Tsinghua University in China used GPT 3.5 to control hard-coded Python scripts, but they face key limitations as well. Although, like specific commands that were programmed inbuilt were executed nicely, scripts that were like coded specifically to meet CSS selectors, and this limited generalizability across websites, meaning only certain websites and certain functions could occur smoothly. Um, so this caused it to be task specific and lacked flexibility in unspecified cases. And in these unspecified cases, there were furthermore no fallback measures for executing errors. Their model simply failed to reattempt the task.
So what we try to do differently compared to the previous works, which were very strong, obviously, we try to use an LLM and give it like a specific tool set of generalized code scripts. So it wasn't website specific. And so when the user would give an instruction, the large language model would have the context of what scripts it has access to, and it would also be given the DOM structure of the website so it would know what buttons it could click. And using that, it would try to perform the action on the website. And if that was unsuccessful, we invoked another LLM, which looked at the error codes outputted by the program and then made suggestions for further iterations.
So the first part of our research was developing these Python-based scripts that were hard-coded functions to for serve as like a layout and foundation for any action that we wanted to perform on the website. For this, we use the Playwright library available widely in Python, and mainly its ability to control our Chrome version effectively and its robustness in handling modern web applications. Um, Made us consider this library to use. We also equipped each function with built-in error checks to ensure if actions fail, the comprehensive list of errors were returned back to the model to further use and recover from. Yeah, and we also used for our LLM Llama 3.18b, which is released by Meta on July 23rd of 2024, so not really long ago. It's a 4 gigabyte model, and it runs pretty efficiently on our local laptops. The laptops we used were our MacBook Pros with M3 Pro processor and 18 gigs of RAM. And this model was run through the Llama applications, which is free to download.
So, how do we tell the large language models exactly what elements were on the website? So, we first scraped the web page using Beautiful Soup and then condensed this to fit the prompt context window because obviously there were so many characters in that first scrape. We fed it through another LLM and instructed it to extract the key list of elements. And then taking that elements, we were able to kind of build a prompt for the large language model. So, a prompt kind of reads like, you have to help this user navigate website and they want you to do X. And here are the available functions, which we told them about the function list before. And then the clickable elements was that key list, and we specified a format. So here, if the user says something like, I'm looking for a pair of shoes under $50, then the model might output a like search bar, type shoes under 50, and press enter. So it, and then we parse that output and perform the actions. So this is kind of from an excerpt from our research paper, but our diagram. So after the user sends commands to the Navigator LLM, it gathers all of the prompt context from the left and performs the action. And if that action fails, it goes to the support LLM over here. And then from there, the support LM looks at what failed. It looks at the other elements that might have been on the page and suggests like you might try clicking something else to get the same result. And it goes back through. If it succeeds, end of story. If it doesn't, it goes back at most 3 times. So kind of the equation for that was the errors and the DOM content are given to the support LM, which outputs a set of suggestions to the Navigator LLM, which then outputs a set of new actions which are performed.
Yeah, to see this play out in practice, we made this example where the user asked the model to take it to the login page. So the Navigator LLM, as he looks at the command and sees the word keyword login, and simply tries to click on login based on what it sees. However, since it cannot judge exactly what's on the page correctly all the time, it prints out the error code that gave it the error, stating that the login element, a login keyword, was not found. Here's where the support LLM kicks in, and it reads the DOM content once more and tries to correct the keyword. So instead of login, it suggests sign in. because that's what's actually available on the website. So it uses its intelligence to judge and suggest actions for the navigator alum, which retries by clicking sign in, which is an actual button on the website. Here we can see this through some demo videos, um, where first one is a simple input where the navigator alum is the first one, and it simply works based on the user prompt as shown here. And you can see as prompted, it navigates to the Halloween tab on the website and is able to scroll without any errors coming into play. Another one here is where a lot of our input can be modified to match what's on the website. For example, the prompt includes the word shopping bag. However, the uh, name shopping bag isn't directly on the website, and therefore you can see it clicks add to cart using matching, like pattern matching, essentially. So you can see it play out here where the navigator LLM successfully um, executes the command based on the DOM content that's available for it to read.
And like the whole premise of this is it's supposed to be like voice input, so you like speak to the model and it's able to perform things. So people that aren't really able to use their hands very well can communicate with their computer effectively. So this is kind of an example of the error handling loop with the support LM. So again, I'm gonna try over here to like click that add to cart button, but with a slightly varied prompt, because obviously users aren't gonna say exactly add to cart. So again, add to my shopping bag. And it's not necessarily that the Navigator LM works on the first iteration. Here you can see it tries to say click shopping cart, which is not found on the website. So then that kind of error code gets sent to the other LLM along with the website content, and then it's gonna read the page and successfully say click add to cart. So it kind of fixes the error that initially occurred. Currently, this runs decently slow on our computers because we have to run the whole model, but hopefully in the future, we're going to be able to maybe use APIs or faster models. And here's what I thought was really interesting. So this is an example of the LLM fully aware of the page, and it's able to like look ahead. So the prompt was to find me some Halloween candy. So obviously it could have just searched up in the search bar, Halloween candy, pressed enter, pretty straightforward. But it does something pretty interesting. It first clicks the Halloween tab and then the Halloween candy tab. So it's aware of what elements are on the page and it's able to successfully like think ahead like 2 pages ahead almost.
And just a quick note about our demos, we were able to integrate some voice integration, voice abilities into this, but for the demo purposes, we decided to manually type in the prompts so you can see the process, how the process of our model here. So our current progress, we as we mentioned, we have submitted a technical manuscript, and it's been accepted to the 16th International Conference on Intelligent HCI, and later will be published in Springer's lecture notes in computer science, I believe, and we were presenting in November of this year. We are always looking to constantly improve and working on a version 2, and if you're interested in collaborating with us, we'd be happy to discuss after this talk.
With our current version, like we obviously only have a few amount of like Python scripts that we're using, and we're using a pretty basic LLM. To develop this further, we'd love to like expand that so it's maybe applicable on a variety of websites. Because right now we tested on like e-commerce websites specifically, so that's kind of the next. Thank you for your attention.
Yeah, I guess we can take any questions you may have.
Can you guys explain like the error handling loop for the support LLM a bit? Like, do you have like a prompt template or something that's just kind of like what would be the most likely next best guess if like I don't know, you know, like you gave the example like you're looking for shopping bag in the DOM elements, so it doesn't find that. Are you just like then suggesting to the LLM like, hey, look for something that's similar to shopping bag? Is that what you're doing, or like?
Yeah, exactly. So our prompts kind of specifically was you've already tried this, you've already tried searching for shopping bag, find something similar to accomplish the same action, and then we added the other context at the page.
Did you have like any results where it would actually like find like it would be like an error, like the error handling would produce an error where like it's not, it found something, it thinks that it's correct but it's not.
Yeah, for sure. So we kind of let it run almost to 4 iterations in most cases. Sometimes it would get it. Most of them would be done by 2, but then sometimes there would be cases where 3 and 4, and sometimes it might not just work. So yeah, it definitely goes through.
A couple questions for the voice. When you did implement it, were you using Whisper? Like, what were you, or had you not gotten that far?
We just use the speech recognition library just to like speech to text. We didn't add any like pre-processing.
And the second question for the like sign in, login, like finding text on the page. Like I know Playwright can load like an entire web page and then allow the LLM to like parse that. Are you using any regexes, or are you just like say if you did sign space in like set for it to look for that, would it find sign in as one word hyphenated, or is that going to take multiple round trips to your support LLM to like triage that? I think this is my question.
It would go into the support LLM. We haven't optimized it now, but it would go into support LLM because it doesn't exactly match the content that's on the page. So yeah, we are looking to optimize things for things like that, but currently we don't have it um, being able to pick up on hyphens and characters like that. Yeah.
Sorry.
Yeah, go.
Yeah, I noticed you were writing in Python. I know LangChain in JavaScript and TypeScript has a JSON tooling, and you were parsing strings. I would just recommend trying going a JSON generation route. It's a little easier to parse than having to do like string concatenation and parsing.
Thank you. Yeah, thank you.
Twofold question. The first part is, how do you evaluate success? Like, do you run a test suite and get a percentage, or is it just like testing out?
Yeah, so we had kind of when we tested these models, we had a list of 100 like randomly generated prompts, and we kind of just fed them through the model one by one, like the program one by one, and we tracked at what iteration it succeeded. So initially, like most, like not that many succeeded in the first, like no iterations. Then first, it kept getting better and better. Like the tasks were successfully completed. We just checked if there weren't any error codes.
Nice. And the follow-up question: did you guys try like a GPT-4 or something stronger in terms of model? And what was the performance diff if you did?
We have not tried that yet. We just used Llama because we didn't really want to deal with APIs. We're kind of low on the budget, so we had to run it locally.
Okay, makes sense. Thanks.
Yes.
So these two LLMs like Navigator and Support, are these backed by different model or is it Llama?
It's still Llama 3 8B. Yeah.
What is the difference between these two LLMs?
Sorry.
I was trying to understand the differences between these two LLMs, like how they are different.
Well, fundamentally they're the same, I guess, but the prompt and it's running in two different like portals. So the prompts are the only differentiator. So it's basically the same.
Any more questions? Yeah.
So did you guys just have like a predefined set of actions that you're, I know you like talked about this really early on. If you could like reiterate that, like you just had like a predefined set of actions, or did you like look into potentially like formulating like an action using the LLM or something like this? Or do you guys just like hard code the actions that were possible?
Well, if you're asking about user instructions,
Yeah.
we had a set of 100 user instructions which we tested on, and that's how we tested for 4 iterations, like 4 times, and then those were our predefined prompts. However, we didn't have much flexibility in like generating them in a specific way. It was kind of just simply random.
Yeah, it's a really good idea to use an LLM to generate it. I think we used the prompts off one of the previous research papers. We kind of modified those to fit the more modern websites. Any other question?
Does the LLM ask for the feedback from the human? Like, is the human in the loop? We can say like, or is
No,
this a single?
not right now. It's not.
Yeah, because nowadays, like there are some libraries coming up, like Autogen, if you heard. Like there are multiple agents working together, and they also ask for the human feedback. as well.
I see. Yeah, we sought to mainly automate this process. If by using, if we could by using another LLM, we thought that would be best because we avoid further human interaction. Because that's our goal is to like simplify and lessen the any interaction that occurs in this process. Since people with limited dexterity often can't handle um, website navigation that precisely, especially with the complexity of websites these days. Yeah.
And then I have a question from our online crew. Robert asks, is there any danger of the LLM generating a destructive action accidentally? Or is there a way for a user to confirm the actions before they're actually taken?
No, that's a really good question. No, we haven't currently implemented it. When I was testing a few days ago, it did kind of go wild, but it didn't do too much. Like I asked it to like find me a bag of candy. So I first navigated to the candy page, and then it started searching for like winter coats. I was like, I didn't know what was going on, but we haven't given it like complete like control over the website to the point where it can do something destructive. So it might just like tweak out a little bit.
One more question. So next steps, are you guys building this like to open source it? You want to start a business out of it, just career, or just for fun and research?
First, we're mainly trying to solidify like our methods and our like going through the research route is our main priority, and this way we can get solid reviews from other peer researchers. For example, we're in our conference that we're going to present, we look to interact with the researchers there, gain their insights, and see how they think our framework is, and weigh any pros and cons. And then we might look to further productize this framework and eventually deploy it as like a consumer-minded solution, and perhaps like an extension on the Chrome browser.
Question. So it's more of a accessibility question. How would it interact with someone who might have a speech impediment or who might have an accent where it's a little harder for the language model to understand what they're saying?
Yeah, so we wouldn't deal with that directly, but there's a lot of other research and programs that do already research this specific space. So for converting that like speech to text, we use like somebody else's program, but there are other like programs doing that accessibility speech to text.